What is function composition? By the end of this episode, you will know what function composition is and why it's useful. My name is Eric Normand, and I help people thrive with functional programming. So this is an important topic because it's something we do all the time. We do function composition in both functional and non-functional styles of programming. Functional programmers and mathematicians have named it. They named it function composition, and they've turned it into a higher order function. So it's something that we tend to talk about probably more than you would in a non-functional language. All right. So what is it? It's pretty simple. It's when you take a function and you call it, and then you take the return value of that function and you pass it to a second function as an argument. Okay, so you're kind of chaining the function calls. So I call function A, or usually in math or as examples, we'll use function F and G. So you call function G, you get the result, and then you take that result and you pass it to function F. And then, of course, you get the result of function F. And so in there's like a special case, okay? Because sometimes you'll need some other arguments, right? Like F will take it as the second argument. It'll take the result of G as the second argument. But there's a special case where you take that return value of G and you pass it as the first and only argument to F. Okay, that's a special case because it's very simple and easy to reproduce in your code, that you can just do F open paren, like I'm using like JavaScript syntax, F open paren, G open paren. Then you put the arguments to G, and then you close the paren and you close the paren of F. Okay, and so now the G is you don't even need to name that return value. You don't need to save it into a variable. You just pass it directly to F. Okay, and if you take this special case, you can actually, because it's so regular, you can actually turn it into a higher order function that is a function that takes F and G and returns a new function that does that same thing, that does the F open paren G. And mathematicians usually use the dot as the operator for function composition when they want to talk about it in a paper or something. So they'll write F dot G to mean F composed with G. Now this gets kind of confusing. And it's one of the reasons why I think function composition is thought of as kind of difficult. The confusing part is that the G is called before F, even though it comes to the right of F. So if I do F dot G, the G is called first, and then the F is called on the result of G. Right? So it looks backwards. It doesn't look like call F, or it looks like call F and then call G, but really the G is called first. And I think that makes it confusing. The reason it is that way is like I said, it's like doing F open paren G open paren, put the args of G, and then close the parens, right? So they're in the same order as if you were to call it directly, right? But for clarity, you might want to move the G out of there, right? Because it's inside out. The arguments get evaluated first before the function gets called on those arguments. But if you move the G above there and you called it like G result equals G, and then you called it with its arguments. And then after that, you did f open paren g result. Okay, I'm trying to talk through code, but the idea is that it's in the same order as something you should be familiar with. It's just when you look at it on its own and that's not explained to you, it looks backwards. So why do we talk about this? Why do we want to turn this into a higher order function? Well, first of all, it's very common to do this. It's common to call a function and pass that argument to the next one. And it's, even though it's less common than the general case, the special case of the single argument is actually still really common. So let's say you wanted to double a number and then square it, right? You could double it, so you call the double function. Then you take the result of that and you pass it to the square function, which then returns the value. Or you could say, well, this is a function composition, and you can call compose with the two functions. And then that gives you a new function, which is the double square, right? And so what it does is it reduces boilerplate. By reifying it, and I have a whole episode on reification if you want to know what that is. I also have a whole episode planned for higher order functions if you want to know more about that. But you're taking this idea that normally you just do in code by embedding the call to G as an argument to F. You're now turning it into an object, a function called compose that can do that. And so now this thing can be manipulated like any other function, right? Like any other value. So this compose function is not just a bit of syntax that your language understands. It's now a bit of, it's a function that your code can understand, that your program can use. And so then you can pass it to other higher order functions like map and other stuff, right? So you're getting leverage by turning it into a first class thing. I do want to say that it's not always clearer to do this, to use compose. It's something that people do use though, and so if you're doing functional programming, you should probably understand it. It's something that you'll see a lot. Now, one place where it really is used a lot is in a thing called point-free style. Now, I have a whole episode planned on point-free style. But basically, point-free style, very simply, is a way of defining functions without naming the arguments. So notice, if I wanted to, I could write a function, right? I call it fg or f.g, right? That's the name of the function. And it takes arguments. Those arguments get passed to g, and then g will, return a value, and then that return value will get passed to f, and that return value of f will get returned from f.g. Right? I could write that function, and I could write it over and over again for different f's and g's. So I could write it for sum and square and double, right? And I can write it for trim and capitalize on strings, right? So there's all sorts of examples that I could write by hand each time. Or I could just call compose and not have to name the arguments, not have to think about, not have to repeat that boilerplate, right? And so this point-free style is a way of building functions without naming arguments. Because just to be very frank, arguments take up a lot of brain space. If you have to name the argument, you have to think of a good name. Otherwise, it's going to be worse than not having one. And they take up code space, right? So you don't want to be naming them if you don't have to, right? If it's not going to add to the clarity. So there's this thing called point freestyle, and function composition is used a lot in it because you don't have to name the arguments. Another cool thing about function composition is that it is associative and it has an identity. So the identity, and there's a whole episode on what an identity is, but notice if I do f composed with the identity function, so the identity function is just a function that returns its argument. So you pass in the number 5, it returns the number 5. You pass in the string hello, it returns the string hello. It doesn't do anything to it. You think, what's the point of this function that doesn't do anything to it? Well, it's just like, what's the point of 0? It represents nothing, right? Representing nothing is actually very useful. And so is representing a function that does nothing. It's now able to be the identity value of function composition. So f composed with identity is the same as f. And identity composed with f is the same as f. So the identity function is the identity value of function composition. Okay, you might want to write that down because it's a mouthful. Right, and then it's associative, which I have a whole episode on that, but real quick, it means the grouping doesn't matter. So imagine I have f composed with g composed with h. I can put the parentheses around the f and the g, or I can put the parentheses around the g and the h, and I get the same thing. I get the same result. The function at the end of the day that I get from that whole big expression is going to do the same thing. And when you have something that's associative and it has an identity, that means it is a monoid. And I have a lesson or an episode planned on monoids and what makes them cool. But that's just a cool thing I wanted to mention at the end. If you don't understand it, just wait for that episode and it'll come. But this is the kind of thing that happens when you start dealing with functions as first-class objects, especially higher order functions. You can start to get these kinds of cool algebraic properties that come out. And I just know when I've talked about this in the past, the really common question is, why do I need this? Why do you need it? And the truth is, you don't need it. You can do manual function composition each time. You can. But then the other question is, well, why do you need anything? You can always just do for loops and go-tos if you want. I mean, if your language has go-tos these days. Why do you use map instead of a for loop, right? Well, basically, because if you can use a map is way less error-prone than a for loop. You don't have to initialize any variables. You don't have to get the end condition right. So if you can use map, it's probably less code than a for loop, but that's not really what matters. What matters is that it's less error-prone. And then the cool thing is that once you have map is a function. Map is something that can now participate in all these other higher order functions. Same with compose. You could do it manually, but then you don't have a function called compose that you can use in other ways. And so this is part of the, I would call it the leverage of functional programming. That you're, just by turning this thing that you do a lot into a function that can now participate in the rest of the ecosystem, you now have this leverage where now you're acting at this higher level. So now you're composing compose, right? You're mapping compose over things, which you couldn't do before. Or you could do it, but you'd have to write out compose each time you wanted to. Okay. So let me recap. function composition is simply when you take the return value of one function and pass it as the argument to the next function. Then you can imagine making a function that just does that. And then you'll realize that you do that over and over, that there's a common pattern, and you could just make a function that takes the two functions and returns that common pattern function. And that one is called function composition. It's the special case. Mathematicians use a dot, and even in Haskell, probably other languages, they use a full stop or period, the period character to indicate function composition, just because it looks like a dot. And because it's so easy to do, it's just a dot, you do it a lot. Okay, so why? It reduces boilerplate, and then it reifies this concept into something that now you can leverage in with the rest of your functions. It's used a lot in point-free style, and it's a monoid. It has an identity, and it is associative. All right. So at the end, I like to give you kind of like I think of it like homework or something that would help you use this knowledge that I've just talked about. I think that it would be a good learning experience to write your own implementation of function composition. It's not hard. Like I said, it's just F open paren G in JavaScript, right? But you need to write a function called compose, let's say, that takes two functions as arguments, does the composition, and returns the return value of them, or returns a new function that does the composition of the two. Okay. You can look it up if you have to, but it's really not, if your language has first-class functions, it is really like a 3-line function. It is nothing big. You don't have to do the full-blown industrial strength one that can handle multiple arguments and things like that. Just a function of one argument composed with another function of one argument. Just try that out. That will really help you understand what it's doing and like sort of why they're in the order they are. Right. All right. So that was a favor for you. Go ahead, do that for yourself. Learn a little bit deeper than what you can in a podcast. But I'm going to ask a favor for myself. If you liked this episode, please share it with your friends and please subscribe. Because if you share it with your friends, then it's just another thing to talk about with them. You probably have coworkers who would like to know a little bit more about this functional programming stuff. And if you subscribe, then you will get the next episode, which also has good stuff that you will probably like if you like this one. Because that's how it is. I will have more stuff coming. So thank you very much and see you next time.